Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is PT-7, Compound Figures with Right Triangles. Start with question number 1, C. Apply what you know about the right triangles to find the perimeter and area of the compound figures below. Round your answer to the nearest tenth. So we have this figure, which you can see is broken into either 2 or 4 triangles, depending upon how you look at it. For the beginning, we're going to focus on the fact that there's 4 triangles. And if you look, each triangle is a right triangle, and the hypotenuse of each of these triangles is not known. So I've labeled each of these as W, X, Y, and Z, and we'll use Pythagorean Theorem to determine what the length of each of these is, and that'll help us get the perimeter. So we'll start with W. We have legs of 2 inches and 4 inches. If we plug that in, we get 2 squared plus 4 squared equals W squared, or 4 plus 16 equals W squared, or the square root of 20 equals W squared. Now I'm going to leave that at the square root of 20 because I don't want to have to deal with the full calculator display at this point. We'll save that till the end. Now I'm going to move down to X. I've got 2 legs, an 8-inch and a 7-inch. Plugging those in, I get 8 squared plus 7 squared equals X squared. 64 plus 49 equals X squared, or the square root of 113. And again, I'm going to leave it just like that for the time being. And move on to Y. So for Y, I have a leg at 7 again and a leg at 2. Plugging those in, 7 squared plus 2 squared equals Y squared, which gives me 49 plus 4 equals Y squared, or 53, square root of 53 equals Y squared. And lastly, Z, I have a leg at 4 and a leg at 8. So 4 squared plus 8 squared equals Z squared. 16 plus 64 equals Z squared, or square root of 80 equals Z squared. Okay, now that I've got these, I can go ahead and determine what my perimeter is. So the formula I've created for this is W plus X plus Y plus Z. The outer areas here, which turn out to be all of the hypotenuses. So we have P equals square root of 20 plus square root of 113 plus square root of 80 plus square root of 53. Add those up, works out to be a full calculator display of 31.32666,357. And if we round that to the nearest tenth, we get 31.3 inches. Now to determine the area, we need to think about not 4 triangles here, but 2. So I'll highlight the first triangle we're going to focus on. So the formula for determining the area of a triangle is 1/2 base times height. So we have a height of 4 inches, a base of 10, because we have to combine the 8 and the 2. So if we plug that in, we get 1/2 10 times 4, or 1/2 40, which works out to be 20 inches squared. And then we have a second triangle over here, which also has a base of 10 and a height of 7. So we have 1/2 10 times 7, or 1/2 70, which equals 35 inches squared. If we combine the areas of both of those triangles, we get the area of the compound figure is 55.0 inches squared. I have 0.0 because we were supposed to round to the nearest tenth. And that completes 1C. Next, we'll take a look at 1D. Again, apply what you know about right triangles to find the perimeter and area of the compound figures below. Round your answer to the nearest tenth. So as you can see, I went ahead and filled in a little bit of information here. The fact is, these 2 lines indicate that the sides are equal. So this is an isosceles triangle. And so whatever I determine this side to be, this side has to be the same. And if you look at the bottom, you can see that this divided line splits the 6 meters in half, meaning this is 3 meters and this is 3 meters. And as a rectangle, you can see that this diagonal cuts it perfectly in half. So this side is going to be the same as this side. So this top is going to be the same as this bottom. So we know the distance of all these pieces. So we need to find what the distance is of W. So we have two legs that we can use to find the hypotenuse. In this case, we have 7 and we have 3. So let's solve for W. A squared plus B squared equals C squared. We have 3 squared plus 7 squared equals W squared, or 9 plus 49 equals W squared. And we have the square root of 58 equals W squared. And we'll leave it at that for now, because again, we don't want to deal with full calculator display. We'll have to punch that in every time, and there's no point in doing that. So we have square root of 58 for these sides. Last piece we need to get is x, and then we can go ahead and find both the perimeter and the area. So for x, we're going to do the same thing we just did. We're going to use Pythagorean Theorem. We have a leg here. It's not the full 12 though, because we have to take 3 off. So we have a leg of 9, and we have a leg of 7, and that'll help us find x. So we have 9 squared plus 7 squared equals x squared. 81 plus 49 equals x squared, or square root of 130 equals x squared. And again, we'll hang on to that for now. Okay, so let's find the perimeter first. So to find the perimeter, we have to add up all the outer edges of this shape. So we have W plus the 6 that we started with, plus x plus the 12 that we started with. And we can plug in values for W and x. We have square root of 58 plus 6 plus the square root of 130 plus 12. And if we add those up, we get 37.01752736, full calculator display. Rounding to the nearest tenth, we get 37.0 meters. So the perimeter of this compound figure is 37 meters. To find the area, you can see we have two triangles here, and we'll focus on both of those. So the first triangle right here, we have a height of 7 and a base of 6. Using the formula, area equals 1/2 base times height. So we have area equals 1/2 6 times 7, or 1/2 42, which is 21 meters squared. For the other triangle, we have a height of 7 and a base of 12. We're looking at the full triangle this time. So we have 1/2 base times height, or area equals 1/2 12 times 7, 1/2 84, or area equals 42 meters squared. Combining the two, we get the area of the compound figure is 63.0 meters squared. Please use the homework that was done for you tonight to help you to solve any additional problems that are on your homework. And remember, the key to success in math is not only working hard, but working smart.